Welcome to EDU World Space.
We're again given properties about an area, for the centroidal axis. We're given actually I bar y, and I bar xy. And we're asked to find some other properties, the area moment about the centroidal x-axis and the principal centroidal area moments. So we're given this, and we're also told that if we rotate our x-axis counterclockwise, we get the maximum area product. Counterclockwise by 67.5 degrees. So if we rotate this by, so if this is ix, ixy, if we rotate that by 135 degrees, we wind up at this point here where xy, I bar x prime y prime is at a maximum. Okay, so we get to that point. So this angle is 2 times theta, or 135 degrees. This is a right angle because this is straight above the center. And so this angle here, phi, is 45 degrees. And so from that geometry, we can figure out a few things. We know that r times cosine of phi, okay, must be c minus iy bar. Okay, so we know iy bar, and we know that r sine of phi, right here. So we also know that this is phi since this is phi. So r sine of phi is minus I bar xy. Okay. So what we don't know things here. We don't know c and we don't know r, but we got 2 equations. And so we can figure out that the tangent of phi is this ratio, and we can then get find c, and it turns out that c is 68 times 10 to the 6th millimeters to the 4th. Right? And then if we know c, we can get r, because then now we know everything in this equation, or this one here even. So we can get r, and r is 28.3 times 10 to the 6th millimeters to the 4th. Okay. So 2 equations, 2 unknowns. We can solve for c and r because we know everything else. Now, for getting other properties here, now we know the center is at the average of I bar x and I bar y. And so now that we know c and we know this, we can find I bar x is 88 times 10 to the 6th millimeters to the 4th. And if we know r and we know c, we can get the maximum. And again, that would be about centroidal. And that is 96.3 times 10 to the 6th millimeters to the 4th. The minimum, c minus r, and that is 39.7 times 10 to the 6th millimeters to the 4th. And that is all we were asked to find.